So now that you guys have learned what a logarithm is, we're going to actually get to start graphing them. All right, so just like exponential functions, there is a growth and there is a decay logarithmic function. So this one will be the growth, just like our exponential function when the base is greater than 1. So remember, this is the inverse. The inverse reflects over the line y equals x. What's going to happen here instead is instead of having a y-intercept at 1, I'm going to have an x-intercept at 1. The growth function is going to grow as we go outwards that direction. And it's going to get closer and closer to our x-axis, which is a vertical asymptote in this one. So they both have vertical asymptotes at x equals 0 until that moves left or right or something. With our decay model, that's when the base is between 0 and 1. So it's a fraction. It's taking a part of something as it goes. Still, they have an x-intercept at 1, and it's going to decay, so continue to go down as it goes on forever and ever. That's pretty much all you guys need to know. It also has a vertical asymptote at x equals 0. All right, so state the following, or sketch the following graphs and state the domain and range. So the first thing I notice, the base is 3. So what's going to happen is I have an x-intercept at 1, and it's going to increase as it goes along forever and ever. All right, so now for the domain and range. So notice it's getting closer and closer to 0 here. So logs can never be 0. So if we think about what a log is, log is saying, say I use the base 2, sorry, you need to write that, log base 2 of 0. Say if I used x as 0, then that would be 2 to the what power is 0. It's not possible. 2 to the 0 is 1, so we could have 1 and then it would be 0 over there, but we can't have the log of 0. So it's going to get closer and closer to that, but never touch it. That's why we have a vertical asymptote there. So it goes from 0 to infinity, gets closer to your vertical asymptote, goes on forever. For the range, it goes up and down forever, so from negative infinity to infinity. That's it. All right, next one. Notice here for this log, the base is 0.125. 0.125 is between 0 and 1, so I know it's going to decay, but it's still going to have an x-intercept of 1, but it's going to go down as it goes. Get closer to your vertical asymptote. So the domain is still 0 to infinity, and the range is still negative infinity to infinity. Cool. All right. Here I notice the base is greater than 1, so I know I'm going to be growth. So I'm going to increase as this graph goes on forever and ever. Domain, get closer to your vertical asymptote, so from 0 to infinity. The range goes up and down forever, so from negative infinity to infinity. All right, that's really it. I hope this was helpful. I will talk to you guys soon. We're going to start messing with moving around logarithmic graphs in the next one, but this one was just about the parent functions. That's really all there is to it. All right, I'll talk to y'all soon. Bye.